Okay, write each expression as a single log. So again, we are just going to be simplifying these log expressions. This is part 3 of your 4.2 section. So we have a half ln of x equal or minus 3 ln of 2x. So we need to use our properties. First one we're going to use is take this coefficient and make it be an exponent up there. So we're going to write ln of x to the 1/2. Same thing here. This 3 will move up, but be careful because there's parentheses there. So we're going to have minus ln of 2x cubed. Then we're going to use our quotient property, or some people say like difference to quotient. So what we're doing is kind of compressing or squishing instead of like spreading it out, right? So it's already spread out. We're just practicing like squishing it back together into having log of one argument. So we have ln of x to the 1/2 divided by 2x in parentheses cubed. Now from there, we're going to go and simplify what is inside these parentheses as best as we can. In order to do that, we would first apply the product power rule here, ln x to the 1/2 over 8x cubed. Now we're going to subtract our exponents. So we have a half minus 3. So just as a little aside, a half minus 3 would be the same as a half minus 6 over 2, which is going to give us a negative 5/2. So that will be down in the denominator. So we'll have ln of 1 over 8x to the 5/2 because we want to have everything in positive, and we're going to put that in parentheses too. So that's our answer. We've simplified as far as we could go. Now for part B, it's similar, but it's a little more complicated. So I do want you to try that as a classwork, but see how it goes. Now be careful because these are all adds and this is a subtract. So this one will have to, I'll go underneath eventually. Okay, so be careful of that. Okay, so I've started you off here. We're going to take this 3. So we have 3 log base 2 of x to the 4th plus 2 log base 2 of x minus a half log base 2 of x to the 6th. So we're going to apply that. It's kind of like the coefficient becoming a power. So that is what I did here. And then that x to the 4th to the 3rd becomes x to the 12th. Then I have plus log base 2 of x squared, so that just came up there, and then this half will go be an exponent on log base 2 of x to the 6th to the half, so that becomes x to the 3rd. So now we're going to compress that and use our difference to quotient property. So we have log base 2. Then we have the x to the 12th is in the numerator. X squared is in the numerator because those are positive. Then we have the minus log base 2 of x to the 3rd. That x to the 3rd has to go in the denominator because we're actually doing not just the difference to quotient, but we're doing the sum to product rule is happening in the numerator as well. Now one more step, we need to simplify this. So we would have log base 2 of x to the 14th over x cubed, which then becomes log base 2 of x to the 11th. That's why knowing your exponent laws is really critical here. Number 3, write each expression as a sum or difference of logs with powers expressed as coefficients. We can call this like stretching out or expanding. So now we're just going the other direction. We're taking these the result that's in the parentheses there, and we're just spreading it all out. So we're going to start with log base 3 of the first factor. So log base 3 of 3. Then I'm going to add, these are all adding, log base 3 of x to the 5th plus log base 3 of y to the 9th. From there, I can use some other properties. So we have log base 3 of 3 will equal 1. That's always the case. So that's like an exponent of 1, right? So it just leaves the exponent. Then we have this 5 can come down in front as a coefficient. So we're just doing like the inverse or reverse thing of what we were doing previously up above. So 5 log base 3 of x. And then this 9 will come down. 9 log base 3 of y. And we can't do anything else with that, so we're just going to leave it. Be really careful that you do write your 1 in there. That would be a common mistake that people just kind of leave that out. They kind of assume it's 0. But remember, it would have to be log of 1 would be 0, not log base 3 of 3. So the property I'm using here, just to remind you, is log base b of b equals 1. Now we have b, where we're going to split it apart. We do need to note that both of these factors are in the denominator. We have 2 factors in the denominator, so we're going to need to put things in parentheses when we write the logs in. Okay, so we have to use parentheses there so that we're going to distribute the negative. Have to be careful with that because those would both be negative down there. So we're going to split this apart, and again, do it as classwork. Pause the video and try it, and then come and check back. I'll work through it with you first. So we first have log base 10, so we just don't write anything in there, but we have a to the 4th. And then we have minus log of 8 cubed, or no, it's 8. And then we have a cube root of b squared is what that is. Now we're going to take this exponent and bring it down in front. 4 log of a. And then when we do this is where we need to have the parentheses. Subtract log of 8, which is 2 cubed. So I'm going to write that right now. Then plus log of cube root of b squared. So I'm going to write that as b to the 2/3. Kind of do that along the way. If you're not familiar with that, review your exponent laws. Now I have 4 log of a. So it's not a base a, it's base 10. But I don't write that in. Minus, and this can come down in front, 3 log of 2. And then I'm distributing this negative here, so it's minus, and I'm bringing this 2/3 in front. 2/3 log of b. And that is all stretched out for that example. Okay, one more page here. We have number 4. If log base b of 2 equals m, rewrite the following in terms of m. Your answer should not contain logs. So this is kind of like a puzzle type thing. And again, it's really to show you how we can manipulate things. We later use this for proofs or solving, and using that substitution that we might need to apply. And it's a really good principle that leads you into calculus. So here's the first one, log base b of a half. So I want to get it in terms of m, so I need to get something looking like log base b of 2. So how can I manipulate those things and use my properties? So this could be split apart. I could write it as log base b of 1 minus log base b of 2. Now I know any log of any base of 1 is going to be 0. So this becomes 0. And now this would be just minus log base b of 2, which is what I'm looking for here. That's m. So it would be negative m would be my answer. Log base b of 4, you could try doing that one and think of it as 4 being 2 squared. So do that as classwork. Probably could do this one pretty easily too. This, again, think of it as 2 to the half. And that should help you out. So go ahead and pause and try those. All right, here are the answers for those. We have log base b of 2 squared. The square would come down as the coefficient. And then log base b of 2 is equal to m, as we've stated up here. So in terms of m, we would have 2m. Likewise, this log base b of 2 to the half is very similar. So that comes down as the coefficient. This log base b of 2 equals m. So we have half m. Last one, we have log base b of parentheses 2b cubed and parentheses. So we need to split this apart, and we're going to write that as log base b of 2, because that's the first factor. So we're adding because it's a product there. Log base b of b cubed. So that's kind of nice. We would have something equivalent here, so that we can use our property. That just leaves us with 3 here. Log base b of 2 is our m. So our answer is m plus 3. So I hope you found that helpful. Thank you for watching, and just think of this as kind of a puzzle or a game and manipulating all these things, and it's kind of fun. I like logs because they're just all about playing with the numbers and the exchanging things in different ways. And so it's as long as you persist in getting from point A to point B and look for different avenues. If you get stuck on things, just ask for hints. A lot of times for the homework, you're going to be able to kind of look at the answer and figure it out. You can kind of reverse engineer. And so that's a good process. Just lots of practice with this helps you get it down fluently. Have a great day.